All right, welcome to geometry, everyone. We are going to be covering day 4 in unit 2. If you did not do the play pause it on Monday, you want to make sure you do it. There is some very good information in there about the laws of logic. There's also some really good practice problems that were assigned to you yesterday. And I think that they can be very beneficial to helping you practice those laws. The laws of logic are things that we have used like a lot in our life, but we never gave them a name. So it's just putting logic that you already know and use and giving it a name. If you'd like extra practice, go ahead and email me. I've been teaching geometry for 10 years. I've got so much stuff, I don't know what to do with it. So if you need extra practice or some extra help, please go ahead and email me. And of course, you're welcome to join me in office hours on Tuesday also. I'm happy to see you on office hours. For those of you who have come to office hours, you know that it's kind of slow. And I love it when you join me and give me someone to talk to and someone to help. So if you need help, office hours are a great place to do that. But if office hours don't work for you, email me. We'll work it out. Alexis, I would love that. Can you remind me at the end? Remind me at the end. One thing I do want to remind students, and I've been getting a lot of emails about this, is once you open a test, okay, so you click on the test and you have to click 3 buttons to get there, right? You have to click on unit assessment, then you have to click on the unit 1 test, and then you have to click start, it's called a quiz, start the quiz or whatever it is. As soon as you hit start and you can see the questions, the timer starts ticking. You have 3 hours to complete that test. 3 hours is a long time for that. Okay, so you can't open the test, say, oh, let me look at it. Okay, close it, and then I'll do it tomorrow. That's not how it works. Once you open a test, you have to finish it in 3 hours. If that 3 hours expires and you haven't submitted it, it's going to tell you have to submit. It's not going to let you change any answers. You either submit it or you keep the 0 that's in the grade book, and you really don't want that. So make sure that once you open the test, you are ready. You have 3 hours to do it, and you are you're committed, right? So if you think you're going to take all 3 hours, make sure you're not planning to leave in 20 minutes. If you lose power or something in the middle of it, email me immediately. Okay, because a lot of emails I'm getting are like, Miss Grandy, I opened the test 3 weeks ago and now I can't do it. If you want to know what the test looks like, do the review. Okay, I make the test and then I make the review. So if you want to know what the test looks like, do the review. There's a PDF there for you to print and to work on yourself, and there's a video of me doing the problems. And if you get stuck on a review question, I can answer those. So you can come to office hours and say, Miss Grandy, I didn't know how to do the review number 17. And we can do that together, and I can help you, and it's not cheating. But if you have the test open and then you ask me how to do something, I can't help you, and I want to so badly. It breaks my heart to have to say I can't help you when you have a test or a quiz open. Please know that. I want to help you, but I can't violate the academic integrity of our school. Okay? So just keep that in mind. The test is not the same as the practice, is it? The test isn't the exact problems, but the wording is very similar and the ideas are very similar. Yeah, I try to make the test as aligned to the questions that you see in class, as similar as possible. Yeah. Did I miss something here? Okay. All right. So today we are covering stuff about properties. We're going to use these properties in some proofs. We're going to start talking about what a proof is. If you did the Get Ready for Geometry folder at the beginning of the year, like in August, you've probably seen a lot of these already, and they're going to review that, and we're going to ease our way into writing some proofs, which, if you ask a parent or grandparent about proofs, they're probably going to make an ugly face and say, oh, I hated proofs. Okay, it's not that bad, and I'm going to take you through it step by step. And these proofs are actually pretty simple today. The properties that we're going to talk about are all properties that we already use when solving equations. We're just giving them some names. Okay, so the first property is the addition property of equality. Big old fancy name for saying if you add the same number to both sides, it stays equal. All right, so let's say I have an equation, and I'm going to make this just a super simple equation. A equals B. Well, if I add the same thing to both sides, let's say I add C to both sides, then that equation stays equal. If you don't like it with the letters, maybe you write it with numbers. If 1 equals 1, you know that's true. Then when you add the same number to both sides, pick any number you want. I like 8. Oh, sorry, 2. Okay, you can use 2 if you want. Well, this is still the same. 1 plus 8 is 9. 1 plus 8 is 9. That's still equal. Okay, so the equal sign is still valid. So if you add the same number to both sides, that equation is still equal. That's what the addition property of equality says. And we've been using this every time we solve an equation. We're just giving it a name. And hopefully you learned these names in Algebra 1. I say hopefully. We'll see. Okay. So the subtraction property of equality works the same way. You have an equation. We'll say A equals B. Then when you subtract the same number from both sides, you're still going to have an equal equation. Awesome. Yeah, if you already have these written down somewhere, you already know these, that's great. You're just one step ahead of us. Multiplication, same idea. You have an equation, but you can multiply both sides by the same number, and that equal sign is still valid. It is still an equal equation. You already know what I'm going to write for division, I bet. You can divide both sides by the same number, and it'll still be equal. The only thing with division, you have to have one little caveat over here. Whatever you're dividing by is not allowed to be 0, because you can't divide by 0. The distributive property you learned in Algebra 1, it says that when you have a number outside these parentheses, you can multiply both parts of whatever's inside the parentheses by that outside number. So here I would take A and multiply it by B, and then take A and multiply it by C, and you keep that plus sign in between. Substitution says that if A equals B, then anytime you see an A, you can replace it or substitute it with a B in any expression or equation. So if I tell you that A equals 7, you already know what B equals, because you can replace the A with the B and say that B equals 7. Okay. The reflexive property, this one, it seems kind of silly, but it says that any number is equal to itself. So 2 equals 2, 7 equals 7, 40 equals 40. Any number is equal to itself. That feels like a silly rule that we need to know, but we are going to be using it quite frequently, especially when we get into triangles. Okay. The symmetric property says that if you have an equation, you're allowed to flip-flop the left and the right side. That's all it says. And we've done this before, right? We've solved an equation and we've gotten 8 equals x. And on the computer screen, it says, what does x equal? And you type 8 because you know that x equals 8. That's the symmetric property. Flip-flopping your left and your right side back and forth, that's just the symmetric property. And the transitive property says that if A equals B and B equals C, then you're allowed to say that A equals C. The transitive property is a very fancy version of substitution. That's all it is. Does that transitive property remind you of any law of logic that you may have learned last class? What do you think? If you think you know which law this transitive property kind of looks like, type it in the chat. You don't have to spell it right. Yeah, Camilla, you're right. And you spelled it right. Bonus points. Not really. Anyone else? All right, that's okay. Make sure you do the play pause it for Monday. But when you do it, The law of syllogism looks an awful lot like the transitive property. The law of syllogism is for like sentences and phrases and logic, and the transitive property is for numbers. Now, these last three laws you were supposed to learn in Algebra 1, but with how crazy our world has been, sometimes your teacher probably may have took this out of the curriculum for time's sake. So if these felt very new or familiar to you, you might want to put them on some flashcards to practice them. All right. So we're going to be using the properties of equality to justify our steps in an equation. Okay. What we're going to do is we're going to write a 2-column proof. A 2-column proof is just a super organized way to show your work. The left side of your proof lists the steps or the statements. Okay, so we'll say statements. And the right side of that proof is going to list your reasons. Okay, and we've been saying this out loud, just not really writing it. But our reason. Oh, why did you get that? Well, I added 2 to both sides or whatever. Things that you're allowed to use as reasons. Okay? You're allowed to use properties. So any of those properties we just talked about. You're allowed to use definitions. The definition of a vertical angle or whatever. You're allowed to use a postulate. What is that? Postulate is a fancy word for rule. We called it the segment addition postulate when we learned segment addition. It was just a rule. Or a theorem, which is another fancy word for a rule. All right. So let's practice doing this. Oh, hold on. Locking the door here. Your attendance word for the day, paying attention, is right. Get it right. R-I-G-H-T, right. Make sure that you get that word in the attendance quiz. Capitalization doesn't matter. I don't care if you capitalize it. I don't care if you do a capital lower, capital lower, capital lower. That would actually be kind of cool. As long as you spell it right, then you'll get the point. Man, I wasn't anticipating having this much fun with this word, but here I am. All right. I'm going to put a poll up there on the screen. Tell me that when you've got your attendance quiz, either write it down or do it right now. That tells me I can move on. Right. R-I-G-H-T. All right. Anyone else out there? Tell me you got it. It's all right. I'll give you a minute here. No, it's a long time. 30 seconds. If you're trying to open Windows and let it load, just jot it down somewhere. R-I-G-H-T. Alexis, I do that too. Spell my name wrong. And then people will reply to my email and I get all offended because they spelled my name wrong. And then I realized I signed my own name wrong. So, yeah. All right, we're going to move on. Here we go. So let's write a proof. Okay, now it doesn't say it here. Sometimes on your proofs, the columns will actually be labeled like statements and reasons. And it'll be written later than that. But the way you start a proof is you always have to start with what is given. You can't answer a question if you don't know what the question is, right? That's not how it works. So the only way that you know this first step is because it was given to you. It's the only way you know. So that's our given. Almost every proof you write is going to start with a given. Okay. Then it's asking you to prove that x equals 7. So essentially, in this algebraic proof, we're just solving for x, and we're going to justify our steps. I like to think of this reasons column as like the column that asks why. Anyone have a younger sibling that asks why, like all of the time? Why? Yes. Yeah. I've got a 7-year-old. She does the same thing, right? Go put this dish in the sink. Why? Right? Like, go feed the dogs. Why? Why? You still ask why. It's not a bad thing to ask why. It's a great way to learn about the world around you. It's just bad when you're just trying to be annoying. But think of that column as the annoying little sibling that's asking why. And you have to give a good reason. You can't just say, because I said so, right? Unless you're a mathematician and world renowned and you know all about math, you can't say that. I did say the attendance word already. Yep. All right. So how did we go from step 1 to step 2? All right. What happened to that -1? What happened? Anyone know? I think some people were typing it and I was talking about something else. Yes, someone wrote it there. We added 1 to both sides. And when you add the same number to both sides, that's the addition property. Addition property. And this is the addition property of equality. Okay, so step 1, 4x minus 1 equals 27. Step 2, 4x minus 28. Why? Because of the addition property of equality. I can add 1 to both sides. Then step 3 says x equals 7. Why? Why does x equal 7? What happened from step 2 to step 3? We divided both sides. Exactly. So that's the division property of equality. I like the names of these because they tell you exactly what they do. The addition property, you add. The subtraction property, you subtract. The division property, you divide. Let's look at number 2. Number 2 says a over -6 plus 2 equals 5. We're going to prove that a equals -18. The reason why I love an algebraic proof so much is I already know the answer. I already know that a equals -18. So if I don't get -18, then I know I did something wrong. So let's see. We start with our given. We can't start without knowing what the problem is. That was given to us. Step 2 says a over -6 equals 3. Well, I had to get rid of that plus 2 somehow. Those of you writing subtraction over there, you are right. This is the subtraction property of equality. All right, I'm going to use an equal sign to abbreviate equality. I do want to bring your attention to one thing here real quick. And this doesn't happen so much in my online classes, but when I was in brick and mortar, it did. So I just want you to be very careful. We have one property called the subtraction property. We have another property called substitution. Okay, subtraction means that we subtract or minus the same number from both sides. Substitution says I can take what one number equals and I can replace it with that in any equation or expression. There is no such thing as subtraction. Okay, no such thing as subtraction. It's either subtraction or substitution, but there's no such thing as subtraction. So please be very careful if you're saying it out loud. Make sure your brain can hear you say the right word. Subtraction or substitution, not subtraction. Okay, just watch out for that. And then I saw some of you put it up here, the right answer in the chat. You are completely correct for number 3. To get rid of this -6 on the bottom, we are going to use the multiplication property. And it's the multiplication property of equality. We're going to talk about properties of congruence in a moment. So because we have equal signs, we're using a property of equality. Let's look at number 3. Number 3 says that -9 times 2x minus 3 equals 63. Let's prove that x equals -2. So I can't start a problem without knowing what it is. So that's why I've got a given here, because this -9 times 2x minus 3 equals 63, that was my given. Okay, so now how in the world did we get rid of those parentheses? What do you think? Oh, yes, very good. the distributive property. We distributed that 9. Okay, then from step 2 to step 3. That 27 went away, and now it's the 63 is a 36. How would I get that 27 to go away? Well, I would subtract 27. Very good. So this is the subtraction property of equality. Okay, why didn't I put property of equality up here in step 2? Okay, well, the reason I did not put the property of equality up here in step 2 is because I distributed that 9, but I didn't do something to both sides of the equal sign. Like I didn't just, that distributive property only worked with what was on the left side. So that's not really a property of equality, because even if I didn't have the equal 63, I could still distribute that. Okay, so when you're working on both sides of the equal sign, that's when we're using a property of equality. If you're only doing something on one side, distributive property, maybe even a simplification or combining like terms, we wouldn't really have to call that a property of equality. What do you think goes in this last step? Yeah, you guys are right. Divide by negative 18, since I'm dividing both sides. That's the division property of equality. All right, let's see. Number 4. If you want to work ahead of me, you're welcome to. I'm going to keep working on this one, though. Let's see. Number 4 says 6x plus 7 equals 8x minus 17, and we're going to prove that x equals 12. So I start with the original problem, and that is given to me. Now, number 2, it just says 7 equals 2x minus 17. The 6x, where did 6x go? I subtracted it from both sides. So we write subtraction property of equality. If you need to solve this off to the side and show all the little steps, you need to show the minus 6x and all of that, you are definitely welcome to do that. Just you don't write it in the proof. You don't put those little steps there in the proof. You just say what you did. So let's see. 17, you're right. It's the addition property. Okay, and then let's see, I want to get rid of a 2, so I'm going to divide both sides by 2. Now, there's no property that says just flip it. However, that's what happened here between 4 and 5. We flipped it. There is a property, has a super fancy name, not really fancy, but that says that you're allowed to flip it, and that property is the symmetric property. Very good. The symmetric property allows me to flip whatever's on the left and the right. Beautiful. And once you have whatever you're trying to prove, then you know you can stop. All right, let's see here. Number 5, they give us this whole big equation here, and we're going to prove that x equals 2/3. So of course, our first step is the original equation because that's given to us. And then the next step, I see a negative 7x minus 14 plus 4x and a 12x minus 24. That is the distributive property, right? You're going to distribute that negative 7 to everybody in the parentheses. You're going to distribute the 6 to everything in the parentheses. So that's the distributive property. Okay, so then step 2 to step 3. Notice that the right side hasn't changed at all. The only thing that's changed is this left side. I had a negative 7x minus 14 plus 4, and now I have a negative 3x. So to combine that negative 7x and the 4x, we call that combining like terms. And you can use that as a reason. You might also see this written as simplifying. It's the same thing. If you want to write simplify, you can. If you want to write combine like terms, you can. It doesn't matter. So why didn't I use of equality here in number 2, even though I was distributing on both sides? So in this one, I didn't distribute the same thing to both sides. I distributed the -7 over here on the left, but I distributed a 6 over here on the right. You can use the distributive property without an equal sign and it still works. That's why. Yeah, that's a really good question. If you accidentally write of equality for something, no one is going to judge you for that. You probably just won't see it on your computer screen as like an option on an assessment. It would probably just say distributive property, but you would still know to pick that one. All right, number 4. I started with a -3x. Now I have a -15x. I had 12x on the right, and now I don't have any x's at all. How did this 12x get over here to the left? Well, we subtracted. Yeah, this is the subtraction property. Of equality, because we subtracted 12x from both sides. Let's see, from 4 to 5, that -14 went away. Added 14, so this is the addition property of equality. Very good. I like that when you're typing it in the chat, you're writing property of equality. That's awesome. And the last one, to get that 2/3, well, you just divide both sides by -15. And there it is. Wonderful. Okay, let's see here. The next 2 examples are completely blank proofs that we are going to write on our own. No big deal. All we're doing is we're essentially just doing algebra, just very organized in our table. Sometimes the person who writes these problems gives you more boxes than you need, and occasionally they give you not enough boxes. If you're writing a proof on your own, you can do it in as many steps as you need. On the computer, you're just going to be filling in statements and reasons. I don't think there's ever going to be a time where you have to write one completely from scratch in this course. When you get into further math classes, though, you'll want to be able to do that. Yay, you're right. The first step is going to be 3x plus 1 equals -14. And that annoying little reason says, why? And you write, because it's given, silly. So now we just have to solve. And we already know the answer. We know the answer is x equals -5. So that's awesome. I want to get rid of this 1. How did I get rid of that 1? Well, I subtracted it from both sides. So that's the subtraction property of equality, because I did it on both sides. And now I'm going to divide both sides by 3. So here's an example where whoever did this clearly had more in their brain than I did, but we were able to do it in 3 steps, and they did it in 4. It's still correct, though, so we're good. And the last one here says 2 times x minus 9 equals -10. Why? Because that was given. All right, I want to solve for x. Let's distribute that too. Why is 2x minus 18 equal -10? Because of the distributive property. Wow. Okay, that says distributive property. My pen went wonky. Let's try that again. Oh, close enough. All right, now let's see. Let's add 18 to both sides. So now it says 2x equals 8. Okay, that's the addition property. I added 18 to both sides. Yeah. And the very last step, get that x by itself. Divide both sides by 2. Hopefully this felt easy for us, especially if we did that get ready for geometry unit there at the beginning. There's one word I want to bring to your attention that did not show up in any of our proofs. Okay, I had a given, I had a prove, I had a given, I had a prove. Notice that in every proof that we've written, I have never once used the word prove as a reason. That is not a reason. Okay, you should never, ever be using the word proof or prove as a reason. Let me write that down over here. Where's my pen? Here we go. The word proof. Yeah. The word prove, those are never going to be reasons, ever. All right, that would be like me asking you why and you saying, well, just because that's what I'm trying to do. No, you have to have a reason. You can use a definition, you can use a postulate, you can use a theorem, you can use a rule. What was the other thing that we said? A property. But you can never, ever use the word proof or prove. And it's going to be tempting. They're going to have like a drag and drop problem. And one of the options is going to be proof or prove. And you're going to see it and you're going to be so tempted because you knew you had to use given. Okay. But prove, proof, those aren't reasons. So you don't use that in your actual proof. That's all you're trying to do is prove that that's true. I hope you heard me loud and clear on that. Okay, you should never find yourself writing the word proof or prove in your reason box. Man, I was so adamant about this in brick and mortar that when students would handwrite it, I would take points off for writing that, like extra points. Don't write the word proof. What's brick and mortar? Like the school building where you would like go and like sit in the desks, not online. Yeah, that's what I mean by brick and mortar. All right, so here's a list of all the properties of equality that we've learned so far today. And you probably already knew them before we even started. The addition property, the subtraction property, the multiplication property, the division property, and the distributive property. We've learned all of those. Substitution, reflexive, symmetric, transitive, we learned those. And anytime that you say that it's a property of equality, that is telling me that you are looking at an equal sign. Property of equality is for equal signs. There's other types of properties, and those are called properties of congruence. Properties of congruence are used when you have a congruent sign. And that's not surprising, but they work the same way. So the reflexive property of congruence says that if you have a segment AB, here it is, segment AB, it's going to be congruent to itself. Just like the reflexive property of equality said that a number equaled a number, well, the reflexive property of congruence says that a segment is congruent to itself. So Alexis is congruent to Alexis. She's congruent to herself. But her age, how old are you, Alexis? Okay, she's 16. Her age is equal to itself. So 16 is equal to 16. But Alexis is congruent to Alexis. So congruent symbols are really used for names. Equal signs are used for numbers. Okay. The symmetric property of congruence is very much like the symmetric property of equality, but it's for segments or angles or measures. It's not for numbers. So for example, I could say segment AB is congruent to segment BC. The symmetric property of congruence says you're allowed to flip-flop those. And the transitive property of congruence, very much like the transitive property of equality, but this is for measures. So I could say that segment AB is congruent to segment BC. And then I could tell you that segment BC is congruent to segment CD. If that's true, then you're allowed to say that segment AB is congruent to segment CD. Okay, so these are very much like the properties of congruence, but they're for measures. If you're ever like not sure, am I supposed to be using a property of equality or property of congruence? Look at the symbol in your equation. If you have a congruent symbol in your equation, you're using a property of congruence. If you have an equal sign you're using a property of equality. Simple as that. Just a few other definitions that we are going to be using as we continue through writing proofs. The definition of congruence. Okay, remember the definition of congruence says that they are congruent if and only if, hey, there's our biconditional, they have the same measure. So segments are congruent. If the segments are congruent, then they have the same measure. Okay, see the difference here? The segment symbols are there to name them. So the segments are congruent. Without the segment symbols, that's talking about a length. So their lengths are equal. And the converse of that is true. Yeah, see why we were learning our P's and our Q's? So we could flip this around for our converse. Converse says if their measures are equal, then the segments are congruent. Okay. We learned the definition of midpoint, but just a little review of that. Midpoint says you have a segment, and this is saying AB. And midpoint is the point in the middle. So if M is the midpoint of AB, then you know that the segment AM has to be congruent to the segment MB. They have the same measure. And then the last, and here's the word postulate. Right? We had the word postulate before. It means rule. That's all it means. So when you see the word postulate, don't get scared. It's just a rule. It says that when you have collinear points, so 3 points on the same line, and B here is in between A and C, then segment addition says you can take one small piece, add it to another piece, and get the whole piece. And we'll probably be using this as we go on in the course. We're writing our proofs also. Okay. Next class, we're going to do a lot more proofs, a little bit more in depth, not just algebra, not just solving for X, but actually geometric proofs. Okay, so we will do that next class. For now, just keep practicing your definitions and your proofs and your algebra. Make sure that you do the practice problems. And if you haven't done the Unit 1 test by now, make sure that you get that going. Hold on one second, Alexis. If you opened the test and it timed out on you and you didn't get to submit it, you're going to have to email me and we're going to have a conversation about opening tests too early, which is not a big deal, but we don't want to be doing that in the future. Okay. Remember that the end of the quarter is October 15th. So anything not completed by midnight on October 15th has to stay a 0. So let's just make sure that we get everything completed. If there's anything you need help on, you know I'm here to help you. You can email me questions. You can come visit me during office hours. I want to help. That's my favorite thing to do. Okay. I love helping students. Everything else is part of my job, but helping you guys, that's why I'm here. Okay. So let me know if I can help you and go do that exit ticket. Go do that exit ticket now.